At certain temperature, a 5.12% solution of cane sugar is isotonic with a 0.9% solution of an unknown solute. The molar mass of the solute. First condition is given as isotonic. Isotonic means two solutions with same osmotic pressure value, then the solutions are considered as isotonic solutions. Osmotic pressure pi is equals to C1 into RT, C2 into RT cancel, C1 is equals to C2. Here the concentration is expressed in terms of molarity. Molarity formula: weight of the solute by molecular weight of the solute into 1000 by volume in ml. Here also weight of the solute by molecular weight of the solute into 1000 by volume in ml, given as 5.12% solution of cane sugar. 5.12% solution of cane sugar means 5.12 grams of cane sugar present in 100 ml solution. 0.9% solution means 0.9 grams of substance solute present in 100 ml solution. Here volumes also remain same, volumes are cancelled, so weight is 5.12. Cane sugar molecular formula is C12H22O11. Molecular weight is 342 grams is equals to 0.9 by M2. Now calculate M2 value to 60.11 gram per mole. So first option correct. Give the IUPAC name of the following compound. First of all, order of priority. Of functional group. Cyanides are high priority groups, after that alcohols, finally halogens. So here cyanide is high priority group. 1, 2, 3, 4, 5. Second position chlorine is present. Fifth position hydroxo group is present. 2 chloro, 5 hydroxy, benzonitrile. Correct order of dipole moment is NH3 greater than, NF3 greater than, BF3. So here NH3 is polar substance. NF3 is also polar. Number of lone pairs are also same. BF3 is non-polar, so dipole moment value is equals to 0. In this case, in case of NH3, all the electrons moves in one direction, so its dipole moment value is high compared with NF3. But in NF3, break the bond between nitrogen and fluorine, electrons are moves towards more electronegative element side. Opposite direction electron movement. That's the reason compared with NH3, NF3 dipole moment value is less. Many products formed in the following reaction with Br2 by NaOH, that is Hofmann bromide reaction, can also be prepared by Gabriel phthalimide synthesis. First of all, this is the reactant. participate in Hofmann bromide reaction, then product contains one carbon atom less compared with reactant. So the product is PHNH2. We know that Gabriel phthalimide synthesis. Gabriel phthalimide synthesis is used to prepare primary aliphatic amines only. Primary aliphatic amines only. Aromatic amine is formed. So this cannot be prepared by Gabriel phthalimide synthesis. Next one. PHCH2 CONH2 Hofmann bromide reaction takes place. Then it gives PHCH2 NH2. This is aliphatic amine. Aliphatic amine. So it can be prepared by Gabriel phthalimide synthesis. CH3CONH2 participate in Hofmann bromide reaction. Then it gives CH3NH2. It is also aliphatic amine. It can be prepared by Gabriel phthalimide synthesis. Next one. 4 CH3CONH. It is a degree amide. So not participate in Hofmann bromide. This is also 2-degree amide. Not participate. Secondary amides are not participated. C6H11CONH2 participate in Hofmann reaction and it gives C6H11NH2. It can be prepared by Gabriel phthalimide synthesis also. So if it participates, cyclopropane carboxymide participate in Hofmann bromide degradation and it gives C6H5NH2. It is a primary aliphatic amine. So it can be prepared by Gabriel phthalimide synthesis. Last one, if it participate, it is also 2-degree amide. So it cannot be prepared. How many can be prepared? How many are participate in Hofmann bromide? And it also prepared by Gabriel phthalimide synthesis. 1, 2, 3, 4. Third option correct. Which of the following is most soluble in water? KSP values are given. First of all, MNS. MNS is a AB type of salt. KSP is equals to S square. Now calculate solubility. Solubility is equals to square root of KSP. Square root of 8 into 10 power minus 37. Simplify. Then we will get 8.9 into 10 power minus 19. ZNS. ZNS is also AB type of salt. S is equals to square root of KSP. Square root of 7 into 10 power minus 16. Then you will get 2.6 into 10 power minus 8. Bi2S3. Bi2S3 is A2B3 type of salt. KSP is equals to 108 S power 5. Then solubility is equals to fifth root of KSP divides with 108. Simplify the value. You will get 1.5 into 10 power minus 15. Finally, take Ag2S. Ag2S is A2B type of salt. KSP is equals to 4S cube. S is equals to cube root of KSP by 4. Simplify, you will get 1.1 into 10 power minus 17. Now which is more soluble? Which solubility value is high? Yes, this solubility minus 8 is big number compared with minus 19, minus 15, minus 17. So ZnS is more soluble. What transition in the hydrogen spectrum would have the same wavelength as the Balmer transition n is equals to 4 to n is equals to 2 in helium plus spectrum? Wavelength 1 by lambda according to Rydberg's equation. 1 by lambda is equals to r into 1 by n1 square minus 1 by n2 square into z square, r into 1 by 2 square minus 1 by 4 square into helium atomic number is 2. Simplify now. R into 1 by 4 minus 1 by 16 into 4. LCM is 16. 4 minus 1 into 4. 12R by 16. 1 by lambda value. Lambda value is 16 by 12R. Simplify. 4 by 3 R. This is the lambda value. Now same wavelength. You can take trial and error method. Take fourth option for hydrogen. 1 by lambda is equals to R into 1 by 2 square. 1 by 1 whole square minus 1 by 2 whole square. For hydrogen atomic number is 1. Simplify. R 1 minus 1 by 4. 1 by lambda. 1 by lambda is equals to 3R by 4. Lambda is equals to 4 by 3R. So fourth option correct. Identify E in this reaction. First of all, benzene. Benzene reacts with C2H5Cl. Benzene reacts with C2H5Cl. Then this is called as Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation. Then A is equals to ethyl benzene C6H5 CH2CH3 ethyl benzene. Ethyl benzene reacts with bromine in the presence of iron. This is called as halogenation. This is substituted benzene. Ethyl group is electron donating group. That's the reason the major product is para position substitute bromine atom. Para bromo ethyl benzene CH2CH3. Now reacts with NBS. NBS, NCS, Cl2 by H nu. All these are favors allylic or benzylic substitution. Allylic or benzylic substitution. Allylic or benzylic substitution. Substitute halogen atom N-bromo. Substitute bromine at benzylic position. Then remove one benzylic carbon. In the place of benzyl carbon, substitute bromine. Which on further reacts with the aqueous NaOH. This is look like haloalkane. Haloalkane reacts with aqueous NaOH. Then it gives alcohol CH, OH, CH3, Br. Now alkaline KMnO4. Alkaline KMnO4 heating. This is side chain oxidation. Side chain side chain oxidation irrespective of carbon chain length, then alkyl group is converted to carboxylic acid group. So fourth option correct. 3.011 into 10 power 22 atoms of an element weighs 1.15 grams. The atomic mass of the element is 3.011 into 10 power 22 atoms. Weight is 1.15 grams. Then atomic mass. 1 mole of the substance contains 6.023 into 10 power 23 atoms. Weight is equals to question mark. 6.023 into 10 power 23 into 1.15 by 3.011 into 10 power 22. 2 times 10. Then simplify. You will get 23. So first option correct. N2 plus 3 moles of H2 gives rise to 2 moles of NH3. In the reaction given above, the addition of a small amount of inert gas at constant pressure will shift the equilibrium towards which side? Remember, first calculate the value of delta N. Addition of inert gas at constant volume. At constant volume, at constant pressure. For example, delta N is equals to 0. There is no effect. Addition of inert gas effect, no effect at constant volume and constant pressure also. Delta N value is equals to negative, or sometimes this is given as delta N value. Delta N value negative means delta N value less than 0. Delta N value less than 0 at constant volume there is no effect, but at constant pressure backward direction. Addition of inert gas, delta N is equals to positive, or delta N value is greater than 0 at constant volume, no effect. At constant pressure forward reaction takes place. Now calculate the value of delta N. Delta N is equals to Np minus Nr. Gaseous products and gaseous reactants we can consider 2 moles of gaseous products, 4 moles of gaseous reactants. 2 minus 4, that is equals to minus 2. The value of delta N is equals to negative. At constant pressure, backward reaction takes place. Backward reaction takes place. Backward reaction means this is left side, this is right side. In the backward direction, right hand side to left hand side. Right to left hand side. So backward direction, here note down, backward direction or left hand side. Forward direction or right hand side. Correct order of energy for tetrahedral complexes. Correct order of energy for tetrahedral complexes is fourth one. We know that according to crystal field theory, the subshell is divided into two sets of orbitals. One is easy, Second one is T2C. In case of this is, I am talking about tetrahedral complex. Dx square minus y square, dz square, dxy, dyz, dzx. Energy dxy, dyz, dzx energy is more compared with dx square minus y square and dz square. Now, so fourth option is correct. Fractional oxidation number are commonly observed in mixed oxides such as Fe3O4. Calculate the oxidation state of iron. 3x minus 8 is equals to 0. X is equals to plus 8 by 3. So statement 1 correct. Fe3O4 is a combination of FeO plus Fe2O3. In FeO, iron exhibits plus 2 oxidation state. In Fe2O3, iron exhibits plus 3 oxidation state. Both statement 1 and 2 are correct. Rate constant for the reaction K is equals to 10 power minus 3 second inverse. Second inverse. So it is a first order reaction. For first order reaction, the integrated rate equation is K is equals to 2.303 by T log of R naught by R. Question is calculate time. 2.303 by K value is given as 10 power minus 3 log of 100 by 75% completed. R value is 25. 4 times log 4 value is 0.6020 by 10 power minus 3. Now simplify, then you will get 1386.4 seconds. Second option correct. Assertion enantiomers have identical physical properties. Identical physical properties. Identical physical properties are have the same melting point, boiling point, density, solubility. Except for the direction of rotation of plane polarized light. Statement 1 correct. Enantiomers are non-superimposable mirror images. Reason also correct. So based on this, both A and R are true, but R is not the correct explanation of Y. So R is not correct explanation of A. Why this is incorrect explanation? Reason R describes what they are, not why they have identical physical properties. That's the reason. The specific conductivity of 0.1 normal KCl solution is 0.0129. K value is given 0.0129 ohm inverse centimeter inverse. The resistance of the solution in this cell is 100 ohms. R is given as 100 ohms. The cell constant is K is equals to 1 by R into cell constant. Constant. Then cell constant is equals to K into R. 0.0129 into 100. Simplify, then you will get 1.29. Second option correct. Order of O2 minus. O2 minus, total number of electrons 17 electrons. Bond order value is 1.5. O2, total number of electrons 16 electrons. Bond order value is equals to 2. The bond order of O2 minus is less than, is lower than, sorry, is lower, is lower than O2. Correct statement. Addition of an electron to O2 occurs in an anti-bonding orbital. Correct. Both the statements correct. Identify the correct product. CH3 CH double bond CH2 plus NOCl. Remember one point. Add halogen. Add chlorine atom to unsaturated carbon which contains less number of hydrogens. Of NOCl, you can assume HCl. It follows Markovnikov's rule. Similarly, then CH3CH, Cl, CH2NO. Based on that, first option correct. The enthalpy change for the transition of liquid water to steam is delta H vaporization is equals to 37.3 kilojoule per mole at 373 kelvins. The entropy change for this process. Enthalpy is given. Calculate entropy. Delta S is equals to delta H by T. Here given in terms of kilojoules, converted to joules, 37300 by temperature 373. Simplify, then you will get 100 joule mole inverse Kelvin inverse. Second option correct. The alkene which gives 4,4 dimethyl pentane 2-one on reductive ozonolysis. Reductive ozonolysis, break the double bond, add left side oxygen, right side oxygen. Then this compound product is CH3C CH3 CH3 CH2 COCH3 plus CH2O. This is also written as HCHO. What is the name of this compound? 4,4 dimethyl pentane 2-one. Based on that, first option correct. The approximate time duration in hours to electroplate 30 grams. Weight is given 30 grams. Time calculate. Current in amperes is given as 5 amperes. Calcium, equivalent weight of calcium. Calcium chloride dissociates Ca2 plus 2Cl minus. Equivalent weight of Ca2 plus is equals to 40 by 2, that is equals to 20. Now according to Faraday's first law, weight by equivalent weight is equals to IT by 96500. Then you want time. Then time is equals to weight into 96500 by equivalent weight into current in amperes. 30 into 96500 by 20 into current in amperes, 5 amperes. Simplify, 0, 0 cancel. Then you will get 289505 seconds. Convert it to hours. Then 28950. This is 28950. Divides with 3600. Then you will get nearly 8 hours. Number of radial nodes. Number of radial nodes is equals to formula n minus L minus 1. For example, 3s orbital, 3 minus 0 minus 1, that is equals to 2. 3s orbital 2. A1. A1. Sorry. Only one option is there. First option. Yes. First option only correct. For a reaction A gives rise to B, delta H is equals to 20 kilojoule per mole. The activation energy of the forward reaction is 85. The activation energy of the backward reaction will be delta H is equals to, what is the formula? Activation energy of forward reaction minus activation energy of backward reaction. 20 is equals to 85 minus activation energy of backward reaction. Activation energy of backward reaction is equals to 85 minus 20, that is equals to 65. So second option correct. CH3 CH2 C triple bond N undergoes hydrolysis. Cyanide undergoes hydrolysis. Then it gives carboxylic acids CH3 CH2. Complete hydrolysis product is carboxylic acid. Now carboxylic acid is treated with, this is first time hydrolysis. Gives amide. Second time hydrolysis gives carboxylic acids. So 2 times hydrolysis carboxylic acid. Red phosphorus by Cl2. Further given as H2O. Okay, this reaction is called as HVZ reaction. Then it gives CH3CH Cl COOH 2-chloro-propanoic acid. Based on this, first option correct. Match the following. Delta S for isothermal expansion. How to calculate delta S? Delta S is equals to NR ln V2 by V1. Take the first condition. V2 is equals to 2V1. That means delta S is equals to NR ln V2 plus 2V1 by V1. Ln 2, NR ln 2, A1. A1, only one option is there. First option. Atomic orbitals must have comparable energies For effective overlapping, this statement is correct. Reason: orbitals with very different energies cannot overlap effectively. Reason also correct. Why cannot overlap effectively? Because electron density cannot stabilize between the nuclei. So effective overlapping and bond formation become difficult. So correct answer. Both A and R are true. R is the correct explanation of A. When aluminum reacts with NaOH, AlOH taken 6 times 3 minus is formed. Check it. Aluminium. 2 moles of aluminum plus 2 moles of NaOH plus 6 moles of H2O gives rise to 2 moles of Na, Al, OH taken 4 times plus 3 moles of H2. AlOH taken 4 times is formed, but not AlOH taken 6 times. Not correct. H2O bent, correct. XeO4 geometry is tetrahedral, but here given XeO4 geometry is pyramidal. This is also incorrect. Fourth option. Match the following. List 2 condition is given. Want half factor, assume complete dissociation. NaCl dissociate, Na++ Cl minus. Total number of ions 2. A2. Only one option, that is first option. In the reaction, A gives rise to products when the concentration of A was reduced from 2.4 into 10 power minus 2 molar to 1.2 into 10 power minus 2 molar. The rate decreased 8 times at the same temperature. The order of the reaction is, generally what we know, rate is equals to K into A power X. We don't know the order. Initially 2.4 into 10 power minus 2, concentration is given. Initial rate is 1, otherwise initial rate is R. R is equals to K into 2.4 into 10 power minus 2 whole power X, equation 1. Next, rate decreased by 8 times. So R by 8 is equals to K into 1.2 into 10 power minus 2 whole power X. This is equation 2. Now equation 1 by equation 2. R whole divides with R by 8 is equals to K into 2.4 into 10 power minus 2 whole power X by K into 1.2 into 10 power minus 2 whole power X. Then simplify. 8 is equals to 2 power X. 2 cube is equals to 2 power X. X is equals to 3. Correct option is 4. The reagent required to prepare metachlorotoluene. Okay. Trial and error. Take the first option. Toluene you can take C6H5CH3. Chlorine in the presence of sunlight. take excess amount, condition is given. So chlorine in the presence of sunlight favors allylic or benzylic substitution. Then it gives C6H5 in the place of hydrogen, benzyl hydrogen. Remove benzyl hydrogen atoms, in the place of benzyl hydrogen substitute chlorine atoms. Now CCl3. CCl3 acts as electron withdrawing group, reacts with Cl2 in the presence of AlCl3. Cl2 AlCl3. Which process takes place? Halogenation process takes place. Halogenation, it is a electron withdrawing group. That's the reason meta position substitute chlorine atom. Finally, ZnHCl. ZnHCl role, reduction takes place. Reduction takes place. Then it gives CH3Cl. So no doubt, first option correct. Which one of the following statement is not true for glucose? Alpha D glucose undergoes mutarotation. Correct. It has 4 asymmetric carbon is Fisher projection formula. Correct. It gives saccharic acid with Tollens reagent. Wrong. Not gives saccharic acid. It gives gluconic acid. Not saccharic acid. It gives gluconic acid. So this is not true. At 400 kelvins in a 1 liter vessel, N2O4 is allowed to attain equilibrium. N2O4 gives rise to 2 moles of NO2. At equilibrium, total pressure is 600 mmHg. When 20% of N2O4 is dissociated, the value of Kp for the reaction. Initially only reactants are present, products are absent. At equilibrium, what is given condition? 20% of the reactants are reacted. 100 minus 20, 2 into 20. So 80, 40 at equilibrium. So total number of moles at equilibrium is equals to 80 plus 40, that is equals to 120. Now calculate Kp. Kp is equals to ppc by prc. P, partial pressure of NO2 whole square by partial pressure of N2O4. How to calculate partial pressure? Partial pressure is equals to partial pressure of NO2. Calculate first of all. Partial pressure of NO2 is equals to total pressure into mole fraction of NO2. That is equals to total pressure is given as 600 into mole fraction of NO2, 40 by 120. 43 is 200. 200 times. Partial pressure of N2O4. Total pressure into mole fraction of N2O4. Total pressure 600 into number of moles 80 by 120. 4 2s, 4 3s, 3 200 times 200 into 2, 400. Now substitute here 200 whole square by 400. 200 into 200 by 400. 2 times 100 times. So second option correct. O2 total 16 electrons. Bond order value is equals to 2. O2 bond order value is equals to 2. A2. O2 minus 17 electrons. Bond order value is 1.5. B3. Third option correct. N2 minus 15 electrons. Bond order value 2.5. B2 10 electrons. Bond order value 1.0. In an adiabatic process, heat exchange with surroundings is 0. Correct. Because adiabatic process, heat remains constant. Delta Q is equals to 0. Statement 1 correct. Temperature of the system always remains constant in adiabatic process. No, wrong. Heat remains constant. Statement 1 correct. Statement 2 incorrect. Which of the following is pH of solution formed by mixing 0.2 molar NH4Cl? This is salt of strong acid, 0.1 molar NH3. This is weak base. Given buffer is basic buffer. Basic buffer is given. So POH is equals to pKb plus log of salt concentration by base concentration. pKb value given 4.75, log of 0.2 by 0.1. 4.75 plus 0.3010, then you will get 5.05. pH is equals to 14 minus 5.05. This is the POH value, but question is calculate pH 8.95. Fourth option correct. Which of the statement about denaturation given below are correct? Denaturation of protein causes loss of secondary and tertiary structures of the protein. Correct. Denaturation leads to the conversion of double strand of DNA into single strand. Correct. Denaturation affects primary structure. No, not affects. Affects primary structure. No, denaturation does not affect the primary structure. Third option. Two particles A and B are in motion. If the wavelength associated with A, lambda A is 33.33 nanometers, the wavelength associated B, lambda B is equals to question mark, whose momentum is 1/3 of A. Momentum P A is equals to 1, then P B is equals to 1 by 3. We know that lambda is equals to h by mv, or mass into velocity is called as momentum. Lambda is equals to h by p. H is Planck's constant. Lambda a by lambda b is equals to pb by pa for two particles. Lambda a value 33.33 by lambda b is equals to pb value is 1 by 3 by 1. Simplify now. Then lambda b is equals to 33.33 into 3. 99.99 nanometers. That is equals to nothing but nearly 100 nanometers. Converted to meters. 1 nanometer is equals to 10 power minus 9 meters. 100 into 10 power minus 9 meters. That is 10 power minus 7 meters. So fourth option correct. The molar elevation constant of water Kb value is given 0.52 degrees Celsius. Molality is given 1 molal aqueous KCl solution assuming complete dissolution of KCl. So here want of factor is involved. KCl dissociate to give 2 moles of ions. I value is equals to 2. First delta TB is equals to I into KB into L. Simplify. 2 into 0.52 into 1, that is equals to 1.04. Delta TB is equals to. What is the delta TB formula? Delta TB, we know that delta TB is equals to TB minus TB naught. Delta TB value 1.04, TB minus boiling point of water 100 degrees Celsius. Then TB is equals to 1.04 plus 100, that is equals to 101.04. Based on that, third option correct. The amount of substance deposit during electrolysis is proportional to the quantity of electricity passed. Correct. According to Faraday's first law. 1 Faraday of electricity deposits 1 gram of any substance. Wrong. Not 1 gram. 1 gram equivalent weight of the substance. 1 gram equivalent of a substance. So statement 1 correct, statement 2 incorrect. First option. Which of the following order is correct for the first ionization energies of these elements? Third option correct option. We know that second group elements IP1 of second group is greater than IP1 of third group. IP1 of fifth group, 5A group, this is 2A, 3A, is greater than IP1 of 6A group. What is the reason? Ionization energy, ionization potential is directly proportional to stable electronic configuration. 2A group NH2, 5A group electronic configuration is NH2 NP3, 3A group NH2 NP1, NH2 NP4. Assertion: order of reaction is always equal to stoichiometric coefficient of reactants. Wrong. Order can determined experimentally, not theoretically. Order depends on the mechanism of the reaction. Yes, correct. A false, R is true. DDT can be synthesized from the chlorination product of which one of the following aldehyde? Acetaldehyde. See the reaction. CH3CHO plus 3 moles of Cl2 gives rise to CCl3CHO plus 3 moles of HCl. Now take the CCl3CHO plus 2 moles of C6H5Cl in the presence of concentrated H2SO4, then it gives DDT plus water. Which of the following species the central atom has the maximum number of lone pair of electrons? SF4. SF4 geometry is seesaw geometry. Only one lone pair is present. XCF4 square planar, two lone pairs are present. ClO3 minus trigonal pyramidal, one lone pair present. I3 minus linear, three lone pairs are present. I minus I, lone pair, lone pair, lone pair. Fourth option. The order of total number of atoms present in the above sample. 0.4 moles of cyclohexane. Cyclohexane formula C6H12. 1 mole of cyclohexane contains 18 into Avogadro number of atoms. Then 0.4 moles contains how many number of atoms? 0.4 into 18 into Avogadro number, that is equals to 7.2 into Avogadro number. Sucrose molecular weight. Sucrose molecular weight is 342. So sucrose C12H22O11. Total number of atoms calculate 20, 30, 40, 45. Okay. 342 grams of glucose. 342 grams of sucrose contains 45 into Avogadro number of atoms. Then 68.4 grams of sucrose contains how many atoms? 68.4 into 45 into Avogadro number by 342. Simplify, then you will get 9 into Avogadro number. So based on this, B greater than A. B greater than A. Two options are there still. B greater than A, B greater than A. Okay. Now 70.2 liters of oxygen at STP. Oxygen at STP O2 form. 22.4 liters of oxygen contains 2 into Avogadro number of atoms. 70.2 liters contains how many number of atoms? 70.2 into 2 into Avogadro number by 22.4, that is equals to 6.26 into Avogadro number. Now second option correct. An organic compound A was hydrolyzed with dilute H2SO4 to give a carboxylic acid and an alcohol. C gives white turbidity immediately. First of all, carboxylic acid plus alcohol is formed. Means the reactant is ester. Ester hydrolysis reaction this is. When treated, turbidity formed immediately. So this is must be 3-degree alcohol. Now 3-degree carbon atom is present in second option. See the chemical reaction. O undergoes hydrolysis, dilute H2SO4, then it gives OH plus alcohol, 3-degree alcohol, gives turbidity immediately. The total number of stereoisomers means geometrical isomers plus optical isomers. First of all, geometrical isomerism is possible. Two geometrical isomers are possible. This is chiral carbon atom Optical isomerism is also possible. Those are also 2. 2 plus 2 is equals to 4. First option correct. At 25 degrees Celsius, the molar conductances at infinite dilutions for the strong electrolytes NaOH, NaCl and BaCl2 are given. Calculate molar conductivity of BaOH twice. According to Kohlrausch law, molar conductivity of BaOH twice is equals to molar conductivity of BaCl2 plus 2 into molar conductivity of NaOH minus 2 into molar conductivity of NaCl. No, BaCl2 is 280 into 10 power minus 4 plus 2 into 248 into 10 power minus 4 minus 2 into 126 into 10 power minus 4. Simplify. Then you will get 524 into 10 power minus 4. Second option correct. Thank you.